Good morning or afternoon or evening. Going to 8.5 today. I have a little bit more confidence in this because I will admit that I hated graphing those things when I was in school. It always drove me crazy, as you can see. But anyway, variation functions, there are three types: direct variation, joint variation, or inverse variation. You can also see it as RECTLY, proportional, or so it could be directly proportional, jointly proportional, or inversely proportional is also a word you might see. The key thing to keep in mind is the direct, joint, and inverse, because your success in these problems just requires a memory of what each type means. Solving them requires that you practice whatever method works best for you. I'm going to show both methods on the first two types, and then I'm just going to go ahead and pick away on the third. But again, whatever method you think is best as I go through these, just pretty much start practicing it, because as you know, again, I believe in all of you, and anything you choose to do, you'll do well. So if you decide to pick the proportions method and go with it over your homework, then by the end of the homework, you'll probably be very good at the proportions method. Same thing if you choose to use what we call the solve and plug method, then by the end of the lesson, you'll probably be pretty good at the solve and plug method. But I probably wouldn't switch until you became, till you had to. For example, if you're teaching a class and have to show both. I usually don't use both. I usually use the solve and plug method, but I don't know. We'll see what happens. It just depends on the problem. And again, kind of like I tell my basketball players, if you can only use one hand on the court, then you're not going to be as effective, because you need to be able to use either one. You never know what the defense is going to give you. So you don't know what the problem is going to give you. It helps if you know both. So even if you want to kind of put yourself in a good spot, just practice both. But whatever it is, there is more than one way to do this. Direct variation is going to be the formula y equals kx. So anytime you see something talking about something varies directly as something else, you're going to use this method or use this formula. And pretty much the phrase y varies directly as x, y varies directly as x, this part right here, means you will put y equals kx. Alright? Now, the proportions method is where you take this y equals kx and you simply put, or you visualize, if y is equal to kx, let's go ahead and put a 1 on this. You don't have to, but like I said, let's go ahead and put a 1 on that. If y1 equals k times x1, that would be the first y is directly proportional to the first x, and the second y is directly proportional to the second x, and we have this same constant k. That means that y1 over x1 is equal to k. It also means that y2 over x2 is equal to k. Well, if k is your common piece, that means that y1 over x1 is equal to y2 over x2, which means you can now say that this first part would be your y1 and y2, which means if y is equal to 6, when x is equal to 32, you would put 6 over 32. And it says find y when x is equal to 8. That means we don't know y, but we do know 8, which means we would put y over 8. That is your proportion. You then cross multiply, making it, 48 over 32, because you would multiply, I guess you would say 48 if you're doing proportions the right way. You do 48 equals 32y, which means 48 over 32 is y. And I think 16 goes into this, giving us the answer of 3 over 2. And so that would be the answer that you have there. So again, proportions-wise, you just got to kind of visualize what the formula is. You take the formula and set them both equal to k. And once you have that, you now have your relationship. So again, once you have that, you say pretty much put your y and x related in this one into a proportion. Put your y and x related in this one and set them equal. And that would be your proportion there. Honestly, I'm going to tell you that the hardest part of this process is setting it up, because again, even if you don't like that, I think you can work that out because your algebra is strong enough. Again, recognizing that k and k are the same, it means that they are linked, which means that y1 over x1 has to equal that, and there's your proportion there. The other way is also known to you, and you used this whenever we found the equation of a line. If you remember doing y equals mx plus b, where we plugged in y, we plugged in x, we plugged in m, we solved for b, and then we plugged all that information back into the problem. Same thing works here on this one for the solve and plug method, but I wanted to make sure you saw some word problems here also. When a group of snow geese migrate, the distance they fly varies directly with the amount of time they are in the air. A group of snow geese migrated 375 miles in 7.5 hours. How long would it take these geese to migrate 3,000 miles? Solve and plug method. Anyway, I just want to see if I could read it. But it says this phrase here. And so you have to kind of pick your variables. That's why they do that in Algebra 1. I see distance as my variable, I see time as my variable, but it says the distance varies directly with the amount of time. That means d is equal to k times t. Again, k is your constant of variation. It's whatever is common in both situations. So using the solve and plug method, here's what you do. You take what you know and you plug them in. So 375 miles is your distance, equals k times 7.5 hours, and you solve for k. So you divide both sides by 7.5. Definitely need a calculator for this one. 375 divided by 7.5 is 50. And so kind of like your rate of change, 50 is your k. And so now what you do is you rewrite this kind of like, again, your rate of change. D equals 50t. Because remember, again, when we did y equals mx plus b, once we found b, we plugged m and b back in. Once you find k, you now plug k back into their formula, and then you take whatever's there. And you want 3,000 miles, so that would be a distance. So you put 3,000 equals 50t. And then, of course, to solve this, you divide by 50. Divide by 50, getting 60. As your time there. So again, this method is the same. Notice you still kind of look about the same because you're still doing a lot of divisions and things like that. But like I said, whatever way looks better for you, practice that. Or like I said, just learn both and kind of make sure that you are balanced in both. Because again, the more balanced you are, I worked out one that I know is on your test. And it actually, I think the last question on this I worked out, and I did it in a way that didn't even make sense until I pieced it all together, because this lesson forced me to look at both methods instead of just kind of sticking into, you know, I do it this way and that's the only way I know how to do it. Okay, inverse variation is, instead of y equals k times x, it's y equals k divided by x. So suppose f varies inversely as g and blah 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 blah. Again, I'm not worried about the method. The setup is the hard part. So f varies inversely as g. That means f equals k over g. Alright? Solve and plug method. Using this, again, if f equals 15, that means plug it in. 15 equals k over when g is equal to 9. So again, if f equals k over g, once I know the formula, which is why you need to memorize that, I can take that information and plug it in. So 15 equals k over 9. To solve this, I'll of course multiply it by 9. 9 times 15, I believe, is 135. And so now, once I have that, kind of like the y equals mx plus b, I put f equals 135 over g. And then I plug in what I have, which is, it says find f when g is negative 6, so f equals 135 over negative 6. Which is negative 22.5. Again, if you want to challenge yourself, work it out using the proportions method. Pause the video, work it out using the proportions method to see if you get the same number, and it should work. But again, I'm trying to keep your time down because I've been killing you with these videos over the last couple days, and I'd like you not to have to sit for 30 minutes. Again, a word problem. The time it takes to distribute flyers to homes varies inversely with the number of students passing out the flyers. Last year, 12 students were able to distribute 1,000 flyers in 4 hours. How long would it take 15 students to handle the same number of flyers? Proportions method. Again, your phrase here is the time it takes to distribute flyers varies inversely with the number of students passing out the flyers. There we go. We know what the relationship should be. It should be k over something. Now we just have to read and look for our variables. Again, we're talking time and with students, or you could say number of students. So I would put T equals K over N. And so you know it's going to be a 1 and a 2 there. So here's what I'm going to do. I'm just going to solve this and pretty much put, because remember, actually I'll do it the right way. So T equals Kn, T1 equals K over N1, T2 equals K over N2. That would be T1 over N1. No, I'm sorry. T times N equals K over here. It would be T2 N2 equals K over here. Again, looking at this, in order to solve this random equation, I would have to multiply both sides by N1. In order to solve this one, I have to multiply both of those by N1. Now, because K again is our constant here, we have T1 N1 equals K, equals T2 N2. So again, here is your constant, or here is your piece here that matches that one. And it looks complex, but it's only because I have to actually explain it before I do it, which I don't think I'll do on the last one. But again, general idea is that now if we were to solve this and we wanted to do it, we would move our N2 to the bottom by dividing, and move our N1 to the bottom, which means it's T1 over N2 equals T2 over N1, yes. Now that I wrote that, good thing this is recorded if you want to copy it. I don't use it that way. Here's what I do. I write down the situations instead of giving all these things here, and so then you put T1, which is your first time, which is 4 hours, right? So 4 equals K over number of students. Again, not number of flyers, because the flyers is consistent. Again, in this case, you're doing flyers the same, which is why it represents your K. But again, 12 is your number of students. That's your first proportion, right? Because again, 12 students in, took 4 hours time. On your second one, it's going to be the time we don't know, so you would put T equals K over number of students, which is 15. So this is still the same as that. The only difference was, again, I had general variables, whereas here I'm plugging them in once I know the relationship. And you might want to put T equals K over N. That way you can use that whenever you make each one. But again, it ends up being a proportion, or ends up being worked out, because with this method you still solve, which means that 48 is equal to K here. It means that 15T is equal to K here, which means that 48 has to be equal to 15T, using the same thing. Again, if you look here, first statement, second statement, third statement, fourth statement, then we cross multiplied, or we pretty much set the two things equal, T1 N1, T2 N2, and then of course you would solve it by dividing by 15, and 48 divided by 15 is 3.2. Again, I would say that if you do not like that method and you want to practice the solve and plug, give it a shot. Actually, we just did, because we did solve and plug here. Find out is 48. You would just put 48 over 15, which is what we ended up doing anyway. But again, if you don't like that method of approach, stop the video, try it one time using the other one. And again, at any point, if you're having issues, please feel free to email me. I do not mind helping you. Actually, I love helping you, because again, I know that you're smart enough for this stuff. You just kind of fall off track, as all of us do, and once I tell you and you get it, it makes me feel better to know I at least helped a little bit. Before moving on, let's analyze what these variations mean. And again, I'm doing this so you actually understand. Looks like I'm going to take up all your time again today anyway. If y equals kx and k cannot change, this is a direct variation formula, and k cannot change, and that means that as x increases, let's say this is 6. If this is 2 and 6, that means that 2 times 6 would be 12. Alright, now if an increase in x leads to an increase in y, again, if that is a 6 and that's 2, then that would be 12. If that is a 6 and that's 3, then that would be 18. If that's 6 and that's 5, that would be 10, then that would be 60. But notice that as this changes, it's going to multiply by the same number, which means that's going to change the same way. This goes up, that goes up, which means that anything that where increase leads to an increase is a direct proportion. So if you have a word problem where they're talking about the number of workers and products made, that would be directly proportional, because obviously if you have more workers, you should be able to make more products in that amount of time. If you're talking about number of hours and videos produced, of course, if you have more hours, you should have more time to make videos. More time. You should be able to make more videos because you have more time to make them. And again, this is just general information for you so you can actually increase your math understanding of things. If y equals kx and k cannot change, then an increase in x leads to a decrease in y. And if you look at it, again, assume this is a number like 100. If this is 100 and that's a 1, that would be 100. If this is 100 and that's a 10, we just increased x, then that would now drop down to a 10. Again, 100 over 1 is 100. So 1 led to a value of 100. 100 over 10 led to a value of 10. So an increase in x led to a decrease in y, which means that this is anytime an increase in one leads to a decrease in the other, it's going to be inversely proportional. For example, number of workers and time to paint a house. Paint the same house. If you had 7 workers painting a house versus 15 workers painting the same house, the time should decrease. Number of errors, grade percentage. We know this probably by experience. I know I do, that if you make more errors, your grade percentage goes down. So again, anytime that happens, you can use that as your situation there. And that's important because sometimes, again, they don't tell you what the variation is. You just have to kind of figure it out. And then sometimes, and this is something we'll kind of see later, they give you a combination. And it'll say something like A varies directly as B and A varies inversely as C. So you'll have to take your understanding of direct and indirect and kind of put that here. And so you know it's going to be a K. A varies inversely as both of them. It varies directly as B, which means B would be attached to K. Alright? A varies inversely as C, which means ignore that, but we know that C should be on the bottom. And there you go. That would be your formula. Again, if A varies directly as B, there's your relationship there. If A varies inversely as C, there's your relationship there. And again, after that, it just kind of gets crazy and all that good stuff. And just doing that example shows me that the last example really doesn't make sense, but again, it just gets crazy. It's just algebra. And they're just testing your ability to think your way through a problem. So 2 more problems real quick. If A varies jointly as B and C, again, A varies jointly as B and C, and A equals negative 96 when B is equal to 3 and C equals blah, 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 blah. A varies jointly as B and C, if you remember, is A equals K, B, C. Again, choose any method, so I'm just going to go ahead and solve this the way I know. And so what I'm going to do is plug in both things, which is, it says A equals negative 96 equals K times B equals 3, C equals negative 8. And then I'm going to plug this in on the second one. So find A, which we don't know A, when B equals 4 and C equals negative 3. So this ends up being negative 96 equals K times negative 24. This ends up being A equals K times negative 12. Again, solving both of these for K. I don't know if 24 no, I don't think it does. And watch it go in there evenly. It does, and your teacher's a genius, obviously. 96 divided by 24 is 4. Over here we end up with A over negative 12 equaling K, and so since that is our common part, we have 4 equals A over negative 12, which of course if we want A, we simply multiply by negative 12 to get negative 48 as your A. I actually like this method better, and I don't even know what I would call it, but I guess it is solve and plug, but I guess it would be called plug and solve. But either way, again, there's really no one way to do it. Just pick the method that works best for you. To me, I like this just because of all the junk going on with it, and it allows me to kind of work my way down to the answer. But again, if you want to try the proportions method, your proportions method would be A equals K BC, and of course you would put A over BC equals K, and these are all ones, which means that A1 over B1 C1 equals, obviously this is going to happen with 2, equals A2 over B2 C2, whatever that is. If you are going to use the solve and plug, which is pretty much what we did here, you use this to find the value of K. You would then take that 4 and put it over here, and watch carefully. If I was to put 4 here and plug in the other information, I think this should work. 4 times negative 3 is still negative 48. So all those methods work. I just wanted to show you that. Again, if you took this thing and plugged in negative 96 over negative 24, I think we saw that here. There it is, negative 96 over negative 24. If you put A2, which would be, we don't know, so A over negative 12, B2 C2 is 4 times negative 3. There's your A over negative 12. So again, everything kind of falls back into place the way you need it to. Suppose x varies directly as y, and I'll just go ahead and work the one out like what we talked about earlier. X varies directly as y, x varies inversely as z. Find z when x equals 8 and z equals negative 6, if z equals blah 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 and blah. I want you to just take a moment. Again, this is on you as your own discipline. Pause the video for a moment and see if you can write the formula for this. Alright. It says x varies directly as y and x varies inversely as z. If x varies directly as y, I should see x equals k y. If x varies inversely as z, then it should be x equals kz. So that would be our start. And again, with all this junk, I honestly think, just from doing it last time, that the safest way to do it would be to plug in everything from situation 1, then plug in everything from situation 2, and kind of get k by itself in both situations. So it says find z, which means I don't know z, when x equals 8. Give me 1 second. I guess it's find y. Has to be find y because I gave me those two variables. Sorry about that. Find y when x equals 8 and z equals negative 6. So you would put 8 equals k times y, because we don't know y, over negative 6 here. Here we would put what did I just do? I think I said find z when blah and blah. I want to say it has to be a y. Let's say that's a y. Has to be a y. So I think it is find x. I think that does make sense, yes. That's what happens when you make videos at 5 in the morning. Or make the worksheet at 5 in the morning. So find x when y equals 8 and z equals negative 6. If you understood that part, that's good. So here we go. Find x, which means put an x when y equals 8. So k times 8 over negative 6. There we go. And then here they give me if z equals 26 when x equals, so they give me all the three relationships. So you would put 8 over here for x, k times y, which is 13 over 26. And again, doing the algebra, you know to do multiply by negative 6, divide by 8. Again, quickly, just making sure you know, number on the bottom, multiply to get rid of it. That's why negative 6 moves up with x. Numbers attached to k, again, we're getting k by itself, so in order to get rid of the 6, we multiplied. In order to get rid of the 8, we divided. There's that part. Over here, you do 26 times 8, which is 208 over 13. So again, over here I multiplied by 26, divided by 13. Once I did that, I now have k and k, which means that negative 6x over 8 equals 208 13, and it ends up being a proportion. 13 times 6, I believe, is negative 78 equals, and I could try the 208 times 8, but I'd rather not. 1664. And then, of course, divide by negative 78. I probably screwed this all up, but negative 21.3. Let me go back and make sure. X varies directly as Y, X, Y, and Z. X, I'm going to pause the video while I do that and make sure that everything's right. SpongeBob would say 5 days later. What I did here to check my answer, and the answer is right, but what I did was I rewrote this formula as y equals, or solved it for k, which means xz over y. I then plugged in that answer, 1664 divided by negative 78, which is what we did here. I used a function I'm going to show you later to actually, no, I just used that answer. So remember that a and s is whatever the perfect number is, so that's actually a perfect fraction. So I took that answer, which is x, times negative 6, which is your original z, or your z that you were looking for, divided by y, which is 8. Again, looking here, find x, which was your 21 point whatever, 8 and negative 6, so here's those numbers, and when I plugged those in I got 16, and the other one said that x was 8, which is why I put it here. Z, which is, I'm getting this from here, is 26 divided by y, and I got the same answer, which means that everything actually did work out. It was just very scary. Sorry for taking another 30 minutes. I don't know my own strength. Other than that, MathXL is there. I did not put many questions there. I did put some questions on there you need to make sure you think about, but again, feel free to text me or email me a picture of whatever's going on, and I will go from there. Have a good day.